For many microcontroller applications, a super loop and some interrupts will serve you just fine. But sometimes you need to do multiple things at once, like respond to user interface events and manage Wi-Fi traffic. That's where multithreading comes in. The ESP32 is built with an underlying framework called the Espressif IoT Development Framework, or ESP-IDF, which uses FreeRTOS as the basis for its scheduler. For ESP32 boards with Arduino support, we can interact with this scheduler in an Arduino program. We first need to set our application core to 0 or 1, depending on if the ESP32 is a single core or dual core chip. Next, we set the delay times for our two tasks, which will be very different. As with any good Blinky demo, we'll assign our LED pin. Next, we'll write our blink task. This uses a while true loop to simply turn the LED on and off at the rate we chose. Because this is Arduino, we need to define our setup function. We configure the LED pin and start the serial port. Next, we use this xTaskCreatePinnedToCore function to start our multi-threaded task. This takes a number of parameters. We pass in the function to run, which is the toggle LED function we defined earlier. We then give the task a name and set the stack size for that task. We don't need to pass in any parameters to that function, so we set it to null. Then we set the task priority to 1, which is a very low priority. We don't need to keep the task handle around, so we can set that to null too. Finally, the ESP32 version of FreeRTOS requires us to specify the core for this task. So we specify the app core here, which we defined earlier. In loop, we just print hello to the serial terminal every 700 milliseconds. Let's upload and run this. If you open a serial monitor, you should see hello being printed out. Take a look at your ESP32 board and the built-in LED should be blinking at a different rate. This is the start of multi-threaded programming, which can get complicated pretty quickly. To learn more and try your hand at some fun challenges, check out my Introduction to Real-Time Operating Systems series.